Who here has heard Aaron Patrick speak, our next speaker? I have not, but I'm told that it's worth sitting through. Aaron has a remarkable talent for delivering detailed and comprehensive statistics in a clear and meaningful way. A native of Kentucky, Aron is a statistician with years of public sector experience in data analytics, quantitative modeling, and project management. Although the title of his presentation is quite long, it seems to go directly to the underlying theme of our conference, which is the potential impact of rising energy costs on the states and the nation's economy. So please help me welcome Aron.
How's it going? So my name is Aron, and I think I have one of the coolest jobs in Frankfurt. So I get to spend my days tracking statistics, and a lot of people are really thankful that I'm doing it because they don't want to do it. But I get to analyze the energy and environmental data, and what's even more exciting is we get to project that data forwards in time. And as Secretary Snavely already said this morning, no one can predict the future accurately. And so we need to look at these forecasts with an appropriate amount of, appropriately sized grain of salt. And I'm going to talk you through it. But I want you to think about statistics as we start talking about it as things that change, numbers that change. So I'm responsible for tracking some numbers that change quite rapidly, including coal production, coal mining employment, but also our state's electricity portfolio, electricity prices, generation, and consumption. And these factors change constantly. Also, the prices of fuels are changing. When we're little kids, we learn Columbus sailed the ocean blue in 1492. And we take that number, 1492, and we ingrain it in our minds forever. But the numbers that we're going to talk about today are subject to change. And particularly true is that the future numbers are subject to change. So keep that in mind. Who can tell me what percent of Kentucky's electricity comes from coal? It's actually in the KAM booklet, and the KAM booklet is wrong. Who knows that number? Or want to venture a guess? That's a great question. That's a great question, Josh. So 93, that would have been right 3 years ago, and that's the number I hear very often. 92, I hear that as well. We were 87% last year. Currently, did somebody say 84, 83? That might be a pretty good guess for what we are right now. I don't actually know what we are today, but it's ballpark correct. All right, so I'll jump into my presentation. But feel free to stop me at any time, and I look forward to answering questions as we move forward. Oh, and I've also, this presentation is online, so if you want to skip ahead or go back, you can download it. And everything that I'm going to be talking about is mostly online in other publications, and so you can look at the white paper with the same title, and you can also download it there. And I'm going to click the green button, and hopefully it goes forward. Nope. Okay, well, can someone click next? Can you guys click next over there? Thanks. Okay, well, while this is standing up here, I'll tell you about some of the additional work that we've done. We gave comments to, well, I've already started, so we gave comments to the US EPA on the Clean Power Plan when it was a proposed rule. And a lot of the modeling that you're going to see here was submitted to US EPA because they're not doing a lot of the econometric analysis that we're doing. And they've declined to do these types of estimates. The EPA does not estimate the implications of changing electricity prices on the larger economy. And I'm going to click, okay, it works. Maybe not. Actually, go back one. Sorry, guys. Awesome. So as everyone in this room probably already knows, our largest share of electricity use is going to our industrial sector. So only about a third of the electricity that's consumed currently in Kentucky is going to residential consumers. Now this is really important. When we start talking about state energy policy or national energy policy, we need to think carefully about how that energy is being used. I meet with students and people in the general public that tell me they don't mind to pay more for their electricity for it to come from wind or solar. And that's fine if that's $10 on your home residential bill or $20 on your residential bill. But what we're going to talk about today are the consumers of that power that aren't the residential users. Those are the manufacturers and many of you in this room. And next slide. So if we take that pie graph and we stretch it out over time, what you'll notice is that Kentucky always has been an extremely industrial user of electricity. So if you go back to the very beginning, that red portion there is the industrial sector. The very beginning of this time series, when our data sets came online, the majority, overwhelming majority of Kentucky's electricity went to the industrial sector. Fast forwards in time to 2012, we were half industrial. What we've seen in the past couple of years is a significant decline in total electricity consumption across Kentucky. The industrial sector is still consuming 40% of that power, but we've seen big declines. The first is in May 2013, the Paducah Gaseous Diffusion Facility, USEC, went offline for the last time. And you can see that scar very clearly bringing down Kentucky's total industrial electricity use. We've also had some changes in some large manufacturers in Kentucky that have reduced that industrial demand further, some very intensive users. But in addition, industrial users are doing energy efficiency like they never have before, and that is reducing to some extent the intensity of our manufacturing. So all of these things are playing together to lower our total electricity consumption. If we could go to the next slide. Thanks. This is our projection, our reference case projection that we just updated last month of what Kentucky's electricity demand may look like in the future. What you'll notice, first and foremost, is that it's declining. We estimate that Kentucky electricity demand will continue to decline into the future. Now, this is in stark contrast to US DOE and US EPA estimates for Kentucky that show growth. The US EPA estimated in 2012, when they did the Clean Power Plan, that our electricity portfolio was going to grow from 94 terawatt hours to 98 terawatt hours. We are currently hovering below 75. So US EPA modeling has a lot of holes in it. And in terms of Clean Power Plan and some other estimates, this will probably work out to our benefit. But remember, the future is never certain. Some of the speakers were talking earlier, you know, if we grow our economy, if we grow the manufacturing in our state, electricity demand could rise. Probably not like it did in the past, but we ran 60 side cases around this one case. And in many cases it's higher, it's lower. So this is not the one and only answer, but this is what we believe to be the most likely. Next slide, please. So if we look at that share of our portfolio, currently 40%, used to be 50%, that is industrial use here in Kentucky, and we compare that to the other states around us, we get what we call the Aron graph, which is the whole data set just splattered on the screen there. That black dot is Kentucky, and the gray dots are all the other states. The red line is the US average. What you'll notice is that Kentucky always has been one of the most industrial electricity portfolios in the United States. The closure of USEC and some other recent changes since 2013 have pushed a few states up higher than us, but we're still hovering across the top. So this leads us to think that we may be more vulnerable than some of these other states. Talk more about that in a second. If we could go to the next slide, please. Well, why are we so intensive? Are we, intentionally wasting energy? No. Kentucky has always had one of the lowest electricity prices in the United States. We're in the top 4 today, and the lowest east of the Mississippi in terms of industrial electricity prices. The law of demand, going back to what Nat Adams said earlier with Economics 101, low prices drives use. And if you're going to open an energy-intensive facility, Kentucky's a good place to do that. We have low and stable electricity prices. Next slide, please. This is nominal electricity prices by month. We're used to seeing these annually, but I did it monthly just because I think it's kind of pretty to watch it change with the variation in our weather up and down. That orange line there is our total electricity price. That green residential is up on top, so those really small users. And then the large users, manufacturers, again, red on the bottom. You can see that generally our prices have remained quite stable. Up until about 2003, fossil fuel prices started to rise. Coal prices, natural gas, oil, all of these correlated fuel prices rose, and the price of electricity rose along with it here in Kentucky. But the good news is that electricity prices actually declined in 2015. So I want to make sure everybody heard me when I say that. Electricity prices actually declined, both in real and nominal terms in 2015. They've been pretty stable. Why? Fuel prices. Natural gas prices are ultra low. Coal prices, due to extreme competition right now, are very, very low. And so our total electricity price that's delivered to the ratepayers has actually remained quite stable. There's really no indication in the near future that this is going to significantly change. If fuel prices remain low, our electricity prices will probably remain low as well. Next slide, please. So these are these same data, except mapped by county. And I did this a few years ago, and I'm sorry I didn't get a chance to update it. But what you'll notice is that in the green, the low electricity prices really are clustered up in the Northwest. And who knows what fuel source they're using? Yeah, I just want to keep you guys engaged here, make sure you're paying attention. Yeah, hydroelectric. And in Kentucky, you can see we've got low prices, particularly along the Ohio River. But there's a lot of variation even in Kentucky with our total electricity prices. So make no mistake, our prices are low and stable because of low and stable coal prices. There's no question about that. There's also no question that in the Northwest, using hydroelectricity is really driving down electricity prices in that area. The fuel that you use, in addition to your state regulations and policy, have a significant impact on your total price. Next slide, please. So this is what I was talking about right at the beginning of our presentation. This is the last pie graph we made of what our fuel mix looks like in 2015, 87%. So we've actually added significant amounts of natural gas combined cycle within the past year. So I think in May, correct me if I'm wrong, Carol, but in May, Run shut off the coal units there and switched over to natural gas combined cycle. That change in LG&E's portfolio had a significant dent in the state's total portfolio. Next slide, please. So taking this pie graph and stretching it out again into an area graph, you can see how our generation portfolio has changed over time. You can see the hydro bouncing up and down with really rainfall and temperature. It's not like anyone is trying to turn it on or off. And you can see our total portfolio rising and falling with economic activity and weather. But one thing I want to point out, in addition that we are historically 92, 93, 94% coal, is that our electricity generation portfolio actually rose quite substantially up until the 2009-2010 timeframe. Since then, our electricity generation has actually declined. Out there on the very right-hand side, you can see 2015. You'll see a marked decline in our electricity generation, and you can see that introduction of the natural gas combined cycle. Next slide, please. So this is the fun part, making projections about the future. And yes, actually, no, this is our Bart Simpson graph. Well, that was it over monthly. And this is our projection for the future. In addition to the Cane Run facility, we've also got Paradise. So Paradise is the single largest consumer of Kentucky coal in the United States and in the world. 2 of their 3 generating units are switching over to natural gas combined cycle. They're adding a gig of natural gas capacity. That, in conjunction with the NGCC facility already online in LG&E's portfolio, will significantly change Kentucky's electricity generation portfolio moving forwards. You can see that we're forecasting moderate declines in our total electricity generation, but you can see this introduction of natural gas coming in there at the bottom. There's not a lot of changes between 2016 and 2030, at least that we're aware about, but in the distant future, there may be. So like Secretary Snavely said earlier, all predictions are wrong. Anytime we forecast the future, we will be wrong. But we are trying our best to look forward to estimate what the future might be like. And we have a variety of different side cases, about 60, wherein fuel prices changed, natural gas prices change, and economic activity change. But they're generally similar to this portfolio here. Next slide, please. So there's some good news in Kentucky's electricity portfolio. There's a lot of good news. We already talked about stable electricity prices, at least for 2015. But another one of the really good news pieces is that Kentucky's electric utilities have reduced sulfur dioxide emissions by, correct me if I'm wrong, I think it's 76% since the year 2000. That is a huge reduction. The red line there shows the emissions rate, the pound per megawatt hour, and the black line shows you the total mass emissions for each one of those years. Sulfur dioxide has almost been eradicated from our electricity generation portfolio. As Secretary Snavely said earlier today, we may be approaching a point where there are diminishing returns. We've almost eradicated our sulfur dioxide and nitrous oxide from our electricity generating portfolio. If you look at the red line, which is the monthly emissions rate, and you look at the very end of that time series, which is the last 6 months of 2016, you can see what the AEP decision to close Big Sandy, the LG and EKU decision to close Cane Run did in terms of our sulfur dioxide intensity. It's fallen substantially. We have other power plants named RD Paradise that will be changing their portfolio in the near future. So our sulfur dioxide intensity will continue to decline between now and 2017. And I talk to people in the public, particularly students, which I really enjoy doing. That's really a fun part of my job is talking to students and teaching students. They tell me that they think air pollution is worse today than it was in the past. Our air, at least for as long as we have had these monitors in place, has never been cleaner. The air in Kentucky is very, very clean. Next slide, please. And I wanted to mention, I forgot to mention, how many of you went on the tour at E.W. Brown yesterday? Okay, so a few of you. And if not, you've probably been to some other plants. E.W. Brown is a really good microcosm of how these emissions reductions have been achieved. LG and EKU spent almost $1 billion there to reduce the sulfur dioxide intensity of that station. And just watching the emissions at that one plant, it's phenomenal. I mean, it's absolutely phenomenal. They have completely almost completely eradicated the sulfur dioxide emissions from that plant. So coal, on average, has a sulfur content of about 3%. Of course, it varies. We have high sulfur coal in the Illinois Basin in western Kentucky and some lower sulfur coal in the eastern part of our state. But the remainder of that coal is largely carbon. So coal is carbon. Our carbon dioxide intensity in pounds per megawatt hour really hasn't substantially changed in a very, very long time. You can see, however, in the past year, because of the energy efficiency that we already talked about, because of the declining generation and declining demand for electricity in Kentucky, our mass emissions fell by 11% in carbon dioxide just last year. So we've had significant reductions in our total mass emissions that Secretary Snavely was already talking about. As our power plants continue to make changes in the near future, that big one, Paradise TVA in western Kentucky, that's going to significantly change our mass emissions. So that's good news if Kentucky were to face carbon dioxide regulation in the near future. I probably need to speed up, so next slide, please. So what? Yeah, so why are we talking about all of this? Well, that's why we started with that pie chart, 40% of this power is going to manufacturers. 2/3 of it is going to businesses within Kentucky. Our electricity portfolio significantly impacts Kentucky's economy. Next slide, please. I'm kind of surprised to see what we get. Oh, yeah, this one. I like this chart. This has 3 clicks on it. So the first click, this first ball that's going to appear is the total number of jobs, 15,000, that we believe we can have in Kentucky to produce electricity. This is counting every single coal miner, every single power plant operator, all the people who work for the utilities, keeping up the transmission lines. 15,000 jobs at most, regardless of how Kentucky chooses to generate electricity. Obviously, the most labor-intensive scenario we've ever modeled was actually biomass, using energy crops to produce electricity. So farming that, delivering it to our power plants. At most, regardless of what method you choose to generate electricity, we're talking 15,000 jobs, coal miners included. Next slide, please. Well, next button. We have 235,000 people working in manufacturing in Kentucky. So this seems like kind of an elementary school slide to put these 2 balls next to each other to show you the scale, but I think it's important just to give you an idea. We talk a lot about maybe creating green jobs with solar and wind and energy efficiency. I talk a lot about coal mining employment. But relative to manufacturing, it is very, very small. 235,000 people working right now and growing in manufacturing in Kentucky, rapidly growing, I should add. Next slide. There's a total of 2 million jobs that depend upon electricity to varying degrees, and that's what we're going to talk about next. Next slide, please. And next slide. We'll skip it. So if we take those manufacturers and we look at how many kilowatt hours of electricity they're using to make a buck, it varies substantially. Over there on the far left, we've got paper at, on average, at 3-digit NAICS level, just over half a kilowatt hour to make $1 of product. And that's followed closely by metals, textiles, minerals, wood, and then that cliff there are chemical and plastic manufacturers. Next slide. This is 5-digit level granularity. So zooming in even closer, so instead of saying metals, we'll say primary metals. And instead of just primary metals, zoom in on aluminum. And this gets really fascinating because you can see that primary aluminum production is over 5 kilowatt hours to make $1. So at 5 cents a kilowatt hour, you guys get the math. This is a significant portion of their total costs. But primary aluminum production is out there on the end. Some of the chemicals are coming back down. But the good news is most manufacturing is much less intensive than these. But some sectors are very, very intensive. Next slide. Surprised to see what we're going to get. I don't have the slides in front of me. So we've run a lot of regressions, and now we're going to get into econometrics. So if you want to go to sleep, go to your safe place. And we've looked at the sensitivity of each one of our economic sectors, including government, which is actually very large, and services, and those electricity-intensive sectors like primary metals and paper and wood. And what we've found is that given a 1% increase in electricity prices, we estimate if you can read the axis there, about a 0.8 something responsiveness for primary metals. What does that mean? If you raise their electricity price by 10%, we expect to see an 8% reduction in their output. And so we've run these regressions from 1970 to 2014, looking at changes in electricity prices, looking at them by county, looking at it by state, looking how prices vary across the country, just like in the map we saw, but also how they vary over time. And we've tested what happens when you raise the price substantially or lower the price substantially. How do they respond? And so what we found is this. Some sectors are extremely responsive. Some sectors are hardly responsive at all. And you may not see it, but there's asterisks next to each sector indicating whether the results are even statistically significant. All of the big ones are significant, but government has no asterisks next to it, meaning that at 0.05 or 0.01 statistical significance, we can't differentiate it from 0. In other words, the government isn't responding to changes in electricity prices the way some of these other sectors are. I have a lot of friends in this room from the electric utilities. You'll notice the electric utilities are way out there on the right. So that's growth. Increasing utility costs generally result in growth for utilities. This should make intuitive sense, though, for us. If we were to raise the cost of power and require the construction of new power plants or renewable energy or whatever it may be, we expect to see growth in that sector. This should make sense as well. If we were to change the price of metals and metal prices were to go through the roof, we would see the metals sector slam over there to the right to growth, and all the other sectors that have to buy that metal, they would say, "Aw," and they would go over there to the left. So this should make sense to us. On the next slide, we've taken the same graph, and I've sized it here. Each ball is sized by the number of employees, I think. Nope, value added in each sector. So what you'll notice now is that those really responsive sectors like paper, metal, and wood, chemicals, and glass, they're not very large. So they're very responsive. If you change their price, they will change their value added, their output, their contribution to our GDP, but they're not very large. Down there, services and government, near zero responsiveness, they are large, but they're not very responsive. But what you'll find is that a small change in the price, because they're so large, that little bit of movement can actually add up to a lot of jobs. The next slide, and thank you for clicking through the slides. I'm sorry the clicker doesn't work. The next slide is the responsiveness in terms of employment. And again, you can see the number of employees in each sector. Next slide. So adding it all up, we can produce another forecast that is ultimately going to be proven wrong. This is a long-term projection for US GDP. I don't want you to focus on the final answer of what GDP is going to be. What I want you to focus on is the difference in the green line and the red line. And that's where we have statistically significant differences. No, the United States economy is not going to crash into the ground if we do some environmental plan that costs 50% increase in electricity prices. No, it won't. Certain sectors will, certain localities will, but the United States economy will continue to grow. But that 10% increase in electricity prices is going to cause the loss of about $142 billion a year. That's big. And the total job losses on the next slide is about 1.01 million. So it's not the end of the US economy. It will continue to grow. But we estimate that there are significant reductions. Next slide. So I'm going to talk off script for a second about the way the US EPA does their regulatory impact analyses. They look at a benefit cost for the United States as a whole. And I have read many of their analyses for various proposed rules and written on behalf of the state responses along with my colleagues to US EPA. They are not providing regional impacts. They say for the Clean Power Plan that the costs and the benefits, the costs are outweighed by the benefits. The benefits of this rule are better, but they're not looking at how various states could be impacted, how the economies of various communities could be impacted. For the Clean Power Plan in particular, they're counting costs in terms of saved lives in Bangladesh and Sri Lanka, but they are not counting the impact on manufacturing here in the United States. The EPA, in response to some of Kentucky's comments, actually said that the academic literature lacks evidence to indicate whether environmental regulation has a net effect, either positive or negative, on the whole economy. We have found lots of evidence in the academic research, and we have added this and sent it to the EPA to provide additional evidence that we believe, yes, environmental regulation does have an impact on the economy. So I want to talk a little bit about the regional disparity on the next slide. We looked at the different intensities of different sectors. Metals uses more electricity than textiles, and textiles uses more electricity than do services. Well, different types of industries are located in different states, and the net effect is that different states have different energy intensity relative to their peers. California and New York, they're at 0.12, are using 0.12 kilowatt hours to make $1, but Kentucky, we're using a half a kilowatt hour for every $1 we make in product. I, for one, am very proud of that. I'm proud that Kentucky makes things. I'm proud to brag about the glass in the iPhone, and I'm really proud to talk about Toyota Camrys. And when I was in California last week, I was excited to see a Ford Expedition made in Kentucky. I, for one, am very, very proud of that. But the net result is that we're using more electricity than other states. So changing the cost of electricity will disproportionately affect communities across the United States, regardless of their energy portfolio. Their energy use and consumption portfolio is significantly different. EPA does not acknowledge this. Next slide. So to take that map and throw it back onto our scatter graph, here we are in dollars per kilowatt hour, or kilowatt hours per dollar, sorry. Black dot again is Kentucky, always has been one of the most intensive. The rest of the country, much less intensive. The US average is very, very low. And right there on the bottom, those gray dots are California and New York, making a lot of money, but not using a lot of electricity. So these types of regulations that affect electricity will disproportionately affect states at the higher end of that usage. Next slide, please. Next slide. So there's going to be a lot of next slides, sorry. So this is Seabury. I went down and looked at the aluminum production there, put my hand on this piece of metal, and I asked Chad, many of you probably know him, I asked, where is this metal going? And they told me to Toyota. This aluminum is actually being used in a Toyota hybrid, so I thought that was really exciting. Next slide. And this is inside that Seabury manufacturing facility. This is where they're taking bauxite, combining it with electricity, and producing that really electricity intensive but really lightweight aluminum. Next slide. This is Nat Adams' facility. He invited us up. This is stainless steel production in Carroll County, Kentucky. They're using electricity to heat the steel, and it is a very, very energy intensive product. I've shown these slides to people in DC. You guys in this room, you already know that we're using a lot of energy to make the products that we're making here in Kentucky. But what we really need help is communicating this, I think, out of state. Perhaps a little bit to students and people in the community in Kentucky, but by and large, this is a message that needs to be carried out of state and to Washington, because I don't think they're thinking about these things. Next slide, please. I made this map to show where primary metal manufacturing was occurring. And what you'll note is that it is clustered. It's clustered largely in the Great Lakes region and near Pittsburgh, of course. Each dot is sized by the number of people working in all of those facilities, and the color represents the type of metal that they're actually producing. It is clustered. Next slide. Adding it all up, we can develop a forecast using these elasticity coefficients and a bunch of other stuff, and look at what the change in employment for this sector is likely to be if you change their electricity price. And I don't know if I can read it from over here, but we estimate that a 10% increase is going to result in a $5.5 billion loss to the value added just from primary metals. And that will result in the loss of 14,000 jobs. Like I just showed on the map, this isn't evenly distributed across the United States. It is clustered. And the US EPA, one, is not measuring the impact on metals or manufacturing, and they're not measuring the degree to which this is clustered across the United States. Metals introduces, an interesting discussion. If we look back in our country's history, during times of war, the government was encouraging coal production and metal production for our national security. We could be, through environmental policy and energy policy, encouraging the displacement of certain key sectors that are key inputs into other sectors. We could be displacing those, not just from our state, but from our country. And I don't think anyone in DC is looking at this. Next slide, please. And next slide, textile manufacturing. So textiles were the most responsive that we found in terms of employment. They're able to staff up and staff down faster, is what we found. And you can see again, it's clustered. So the textile manufacturers are not evenly distributed. There's not one of them. They're across the Piedmont region in the Carolinas and in Georgia. So the impacts on textiles will be felt in that region. Next slide, please. So textile manufacturing, we found that a 10% increase would result in about 16,000 lost jobs. Next slide. Next slide, chemicals. Chemicals are more evenly distributed across the United States. But on the next slide, you'll see that they're one of the more responsive in terms of value added. I can't read that, but I think it's $14.2 billion annually for a 10% change in electricity price. Next slide. Papers. Next slide. So I'm sorry if these are boring, but you won't find these maps anywhere else. So if you want to download them and steal them and use them for whatever else, these were really exciting to make. Paper manufacturing is a little bit more dispersed across the eastern United States. Next slide. But we found that a 10% increase will result in 20.5 thousand jobs lost. So it's a pretty significant. What you'll notice across all of these individual sectors that I've highlighted in the United States as a whole is that, yes, our economy will continue to grow. And yes, these sectors will continue to exist. But there is a statistically significant responsiveness that's visible in these forecasts. Next slide. Cool, I'm getting to my conclusions. So you guys survived, congratulations. Next slide. So I'll leave that up there and I'll go off script again. This is something that needs to be discussed in Washington, and to the extent that anyone in this room or anyone that you know has a louder voice than what we are able to exert from this podium right here, please carry this message elsewhere. We have a difference in our modeling that we're really proud of, and that's that we are 100% transparent. All of our equations, all of our data, everything is available for download. And if you have a question about it, you can pick up the phone and call us, and we're happy to answer your questions. In a second, I'll show you a link to an Excel spreadsheet where you can actually download all of the equations and data, and you can interact with it and run your own simulations. That's in stark contrast to US EPA. We've had numerous requests for data and information, and we have been told no. Or we've been told yes, but then it never happens. We are a white box, not a black box, so we show you what went in. And if there's an error in our work, or if there's an error in any one of these forecasts, I invite anyone and everyone to improve upon it, to build upon it, to take this and go the next step and calculate what those elasticities ought to be if these aren't the right answers. But it's definitely an important discussion that we need to be having, and we're not having. In total, we estimate that a 10% increase in electricity prices is going to reduce employment by 1 million jobs. So that's an awful lot. And on the next slide, I think I've got links to this presentation, our paper, and that interactive Excel workbook if you want to go and play with it. But I am happy to answer any questions that anyone has, if there are any. Yes, sir. Yep. You know, we've tried to communicate to the EPA, the Energy and Environment Cabinet has, and Secretary Snavely will be the one that has to ultimately do that. But we have tried to communicate the overall vulnerability of our economy. I should have mentioned in those graphics when you're looking at the different sectors, part of the reason that some sectors respond, including services, to changes in electricity prices is because there's this notion of embodied energy or embodied electricity. That's what you were talking about, that you take a lot of electricity to make a primary metal like aluminum, but then that embodied electricity is then used to make that Camry hybrid. And so you'll see the responsiveness in automotives in our modeling, but it's not as responsive as the primary metals were. But all of that is inherent. You have a follow-up question?
Yeah, I was going to say, for automotive, it actually was more on the turbos and the superchargers that were implemented during the quick ramp up of the fuel economy. So,
Interesting.
and to your point, it would go on even further with regards to building materials and affect everything at a consumer level.
That's a good point. Any other questions? Yes, sir.
You had a slide mentioning the cheap power in the Northwest.
Yep.
Like the hydroelectricity.
Yep.
And the Governor Bevan mentioned, Kentucky got a huge resource of water. And in your portfolio of where we're going, you showed an increase in natural gas production in Kentucky. Why not hydroelectric? What's the whole idea there? We've got so many dams now that we can't have any more.
So my teammates and I over the past 7 years have looked a lot into our ability to expand all of our options. In our models where you're seeing that projection of natural gas combined cycle, that's not because we're telling it to use natural gas. Our model has a very large data set of capabilities. Things that it may choose to implement or not implement, including wind and solar. It has a plethora of biomass resources, everything from chicken litter to energy crops, and yes, hydroelectricity. We estimate that there's about 900 megawatts of additional hydroelectric capacity that could be added in Kentucky. And actually in the portfolio model runs that go out into the distant future, the model does often pick to add that hydroelectric capacity in the future. In the near term, it's not picking it for a couple of reasons. The first is electricity demand isn't growing at the rate that it used to, and the model doesn't need a lot of new power. We are actually long on generating capacity here in Kentucky. We do not need to meet our own domestic load, the amount of generating capacity that we have. But the second reason that the model is picking natural gas is because, I'm sorry, unequivocally, natural gas is the least cost option available in the near term. Let me correct that. The least cost option sometimes is running your existing coal plant. So if you've got an existing coal plant in place, running it into the distant future is probably going to be one of your least cost options, along with new natural gas combined cycle. It's difficult for hydroelectric capacity at 8, 9, 10, 11 cents per kilowatt hour to compete with coal and natural gas down there at the sub 5 cent range. I should also note, though, that while there should be no question in this room or in Kentucky that our low and stable electricity prices are a direct result of our dependence upon our local and abundant supply of coal, I hate to say it, but into the future and in the present, our options are going to be different. Coal is not going to be long-term always the least cost new build option. The reason we're seeing our utilities switching over to natural gas is because that's their least cost option that complies with the environmental regulations that they have. They're not picking coal for any other reason other than that is the least cost compliant option. But into the future, look out, because renewables are going to start to play a bigger part, I think. Wind and solar prices are coming down and are increasingly competitive with some of the older traditional options that we have. So into the distant future, I think that least cost mandate will actually drive Kentucky to increase our dependence upon a variety of renewables, perhaps including hydro. Since I'm not operating from a script here, I should say that the views expressed here do not reflect the views of anyone, maybe not even me. Are there any other questions? Okay, well, I don't know how I did on time, but thank you guys.